Hello everyone, this is Shrawan sir, making maths simple for you. Welcome to my YouTube channel Karna Academy. Today's topic is the principle of mathematical induction. Dear students, in this video we are going to discuss the principle of mathematical induction, and by using the principle of mathematical induction we are going to solve some of the most important formula of sequence and series, which is the sum of the first natural numbers, the sum of the squares of first n natural numbers, and the sum of the cubes of first natural numbers. Here we go. Dear students, at first let us discuss what is the principle of mathematical induction. Principle of mathematical induction. Dear students, in order to prove any result or any formula by using the principle of mathematical induction, at first we have to suppose the given statement as Pn. Then we prove that the statement is, at first we prove that the given statement is true for n equals 1. Then we prove that the given statement is true for n equals k plus 1 whenever it is true for n equals k. So let's write down the statement of the principle of mathematical induction. Dear students, according to the principle of mathematical induction, at first we have to suppose the given statement involving natural number as Pn. If a statement Pn is, if a given statement Pn is true for n equals 1, and again if it is true for n equals k plus 1 whenever Pn is true, whenever Pn, that means the given statement, is true for n equals k, then the given statement will be true for all the natural numbers n belongs to n. Then the given statement Pn will be true for all the natural numbers n belongs to n. So dear students, mainly there are three steps according to the principle of mathematical induction. If we have to prove any problem according to the principle of mathematical induction, then there are three steps. At first, the given statement we suppose as Pn, then we prove that the given statement is true for n equals 1. Then we assume that the given statement is true for n is equal to k, and after assuming that the given statement is true for n equals k, we prove that the given statement is true for n equals k plus 1. Then we conclude that the given statement is true for all the natural numbers n belongs to n. So this is called the principle of mathematical induction. So dear students, now let us use the principle of mathematical induction and prove the most important formula of sequence and series. So here we go. Dear students, at first let us use the principle of mathematical induction to find, or we can say to prove, the sum of the first n natural numbers, which is equal to n times n plus 1 divided by 2. So dear students, in the previous exercise of sequence and series, already we have proved all the formula related to sequence and series, but in this exercise we are going to prove the formula of sequence and series by using the principle of induction method, which is also known as indirect method. Dear students, in the principle of mathematical induction, the problems are proved by making observations or making experiments. We don't use any other formula which are already established, like theorems, definitions, formula, axioms. We don't use any other formula. We prove it by making observation or experiments. So let's prove the first formula of sequence and series. Dear students, we know that the sum of the first n natural numbers is given by the formula n times n plus 1 over 2. Now we are going to prove this by using the principle of mathematical induction. Dear students, the first step is the given statement, or we can say the given problem, we have to suppose as Pn. Let Pn be the given statement. Dear students, at first we have to suppose the given statement as Pn. Pn means the statement involving natural numbers, where n is a natural numbers. Therefore, the given statement we can write as Pn such that 1 plus 2 plus 3 plus n equals n times n plus 1 divided by 2. So dear students, our given statement is to find the sum of the first n natural numbers, which is equal to n times n plus 1 divided by 2. Now, according to the principle of mathematical induction, at first we have to show that the given statement is true for n equals 1. Dear students, in the first step, we have to take the value of n equals 1. So when we take n equals 1, that means if the number of terms is 1, then in LHS we'll have just one term, which is equal to 1. So if we take the value of n equals 1, that means if the number of terms is 1, then in LHS we have got just one term, which is equal to 1. Dear students, now we'll put the value of n equals 1 in the right hand side of this given statement. In RHS we have n times n plus 1 over 2. Dear students, now if we put the value of n equals 1, then we must get LHS and RHS both equal. So the value of n we have taken 1. So if we put the value of n equals 1, then we get 1 bracket, the value of n is 1, 1 plus 1 divided by 2. So after calculation we get the value of RHS also equal to 1. So dear students, so if we take the value of n equals 1, then the value of LHS and RHS both we have got equal. That means this given statement satisfies the first condition of the principle of mathematical induction. Dear students, now the second step of the principle of mathematical induction is that we have to suppose the given statement is true for the natural number n equals k. So dear students, now we have to assume that, let us assume that, let us assume that let us assume that the given statement, that means Pn, let us assume that Pn is true for n equals k. Then we get dear students, we have to suppose that the given statement is true for n equals k. So now the given statement, if we put the value of n, if we put the value of n k in the given statement, then our statement will be pk such that 1 plus 2 plus 3 plus dot 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 dot. We have to replace n with k. Then it is equal to k times k plus 1 divided by 2. So dear students, we assume that the given statement is true for n equals k. That means we'll put the value of n k on both sides of the given statement. That means we'll put the value of n k on the left hand side, and again we put the value of n k on the right hand side, and we assume that the given statement is true for n equals to k. So dear students, we have assumed that the given statement is true for n is equal to k. Then if we put the value of n, if we put the value of n k in the given statement, then our statement will be 1 plus 2 plus 3 plus k, n we have to replace by k, then we get equals to k times k plus 1 divided by 2, k times k plus 1 divided by 2, and we suppose this as equation 1. Dear students, so after assuming that the given statement is true for n is equal to k, we have got the statement Pn in terms of k. Now we go to the next step, which is the third step. Dear students, now in the third step, we prove that the given statement is true for n equals k plus 1 whenever the given statement is true for n is equal to k. So let's put the value of n equals k plus 1 when n is equal to k plus 1. So this is the third step. When n is equal to k plus 1, dear students, now after assuming that the given statement is true for n equals to k, now we show that the given statement is true for n equals k plus 1. So we have to write down language. Now we show that the given statement that means Pn is true for n equals k plus 1 when pk is true. That means when the given statement is true for n equals to k. Dear students, now we are going to prove that the given statement is true when we take the value of n equals k plus 1. So dear students, at first we write down the terms from 1 to k, because already we know that the given statement is true up to kth term. So we just copy up to kth term. Then we put the value of n, k plus 1, which is equal to, dear students, in the given statement, if we replace n by k plus 1, then we get 1 plus 2 plus 3 plus dot 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 plus k plus 1 equals k plus 1 k plus 1. So we have put the value of n k plus 1, then we get k plus 1 times, if we substitute n by k, then we get k plus 2. If we put the value of n k plus 1, then we get k plus 1, then plus 1, that means k plus 1 divided by 2. So dear students, now we have to prove that this statement is true. By taking LHS and RHS, we have to show both equal. So let's first take LHS. Dear students, let us take first LHS of this statement. LHS is equal to 1 plus 2 plus 3 plus 1 plus 2 plus 3 plus dot 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 plus k plus 1. Dear students, by solving this, we'll find out the sum of all the terms up to k plus 1th term is equal to k plus 1 times k plus 2 divided by 2. So we have to, dear students, the sum of the terms from 1 to k. We have already found k times k plus 1 divided by 2. So by 1, the sum of the terms from 1 to k, we have k times k plus 1 divided by 2. Now the last remaining term is k plus 1. Dear students, now if we take the LCM, then we get k plus 1 plus 2 times of k plus 1. Dear students, let's solve it. Dear students, let's solve it now. K plus 1 we can take common. So if we take k plus 1 common, then the remaining term will be k plus 2 divided by 2. So dear students, if we look at the right hand side of the statement, when we take the value of n equals to k plus 1, on the right hand side we have got k plus 1 k plus 2 divided by 2. So we have got the value of RHS. So dear students, now we can say that the given statement is true for n equals to k plus 1, because the value of LHS and the value of RHS both we have got equal. It shows that the given statement is true for the given statement Pn is true for n equals k plus 1 whenever Pk is true. When Pk is true, dear students, now we have to write down the conclusion. Now we can say that the given statement is true for all the natural numbers n belongs to n. Hence, by the principle of mathematical induction, hence by the principle of hence by the principle of mathematical induction, Pn is true for, that means the given statement Pn is true for all the natural numbers n belongs to n. Hence proved. So dear students, so we have proved that the sum of the first n natural numbers is equal to n times n plus 1 divided by 2. So dear students, in order to prove any given statement by using the basic principle of counting, at first we have to show that the given statement is true for n equals 1, then we prove that the given statement is true for n equals k plus 1 whenever it is true for n equals k. So dear students, by using the principle of mathematical induction, we can prove any formula involving the natural numbers. Thank you. Thanks for watching this video. Next time we'll meet with a new content. Till then, bye. Have a nice day. Thank you.